Okay, so now we're not talking about angles, we're talking about segment lengths. So this time, if we have two chords intersecting on the interior of the circles, we already know the rule about angles, but let's talk about the rule for segment lengths. So then the products of the lengths of the segments of the chords are equal. What that means is that if I labeled this X, this Y, this A, and this B, if we took X times Y, that would equal A times B. So that's one of the rules. Another rule is if I have two secants intersecting on the exterior of the circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. What that means is that if I labeled this X and this Y and this A and this B, then X, which is the outer portion of that upper secant, times the whole secant, X plus Y, would be equal to the outer portion of the other secant times that whole secant, A plus B. And then one last rule is that if I have a secant and a tangent intersecting on the exterior of a circle, what happens is that if you take the tangent squared, so I'm going to label my tangent A. So if I do A squared, that would be equal to the outer portion of my secant times my whole secant. So it would be equal to B times my whole secant B plus C. So let's get started with these rules. So for numbers 40 and 41, it looks like all of these are related to two chords intersecting on the inside of our circle. So what we do is we take a portion of one of my chords times the other portion of that chord, and we set it equal to a portion of my other chord times my other portion of that same chord. So here I have a 2x is equal to a 12. Dividing by 2, I get x is 6. All right, so the next one. This time, this portion of my chord and this portion of my chord are equal, so I can label this x. So if I do an x times an x, that would be equal to 12 times the other portion of that chord, 3. So I get an x squared is equal to a 36. Taking the square root of both sides, normally we would do x is equal to a plus positive or a negative 6. But x is a portion of a chord, so x cannot be negative. It needs to be just a positive 6. All right, so my next one, if I take a portion of this chord, x, times the other portion of that same chord, 5, that would be equal to this portion of this chord, 3, times this whole portion of this chord, a 5 plus a 2 is a 7. So I have a 5x is equal to a 21, and dividing by 5 on both sides, x comes out to be a 4.2. Next one, same thing. I have x times 4 is equal to 3 times 2. So I have a 4x is equal to a 6. Dividing by 4 on both sides, x comes out to be a 1.5. Next one. I have, this is 6 times x is equal to 7 plus a 2 is a 9 times, we don't know the other portion, but if my radius is 7, then this other portion is going to be 7 minus this little 2, because that would be the radius, so it would be a 5. So I have a 6x is equal to 45. Dividing by 6 on both sides, I get x is equal to 7.5. Okay, next one. I have x times 5 is equal to 6 times this other portion is equal to that other portion, so 6. So I have a 5x is equal to a 36. Dividing by 5 on both sides, I get x is 7.2. So that's all the chords intersecting on the inside of the circle. Now, for the next one, A, not B. A, I have 2 secants intersecting on the outer portion of the circle. So what I do is I take the outside of one of my secants times my whole secant. A 9 plus a 5 is a 14. And that would equal the outer portion of my other secant times my whole secant, which is x plus 6. So then to find x, I'm going to do a 5 times 14, which is a 70. And then distributing the 6 in, I get a 6x plus 36. Subtracting that 36 over, I get a 34 is equal to a 6x. And then dividing by 6 on both sides, I'm going to just round. X becomes approximately, I'm going to round to the nearest tenth, a 5.7. Okay, next one. I have a tangent and a secant intersecting. So what I do is I take my tangent squared, so 6 squared, and that will equal the outer portion of my secant times my whole secant, which is x plus 2. So I have a 36 is equal to a 2x plus 4. Subtracting both sides by 4, I get a 32 is equal to a 2x. And then dividing both sides by 2, I get x is 16. For the next one, I'm back to 2 secants. So for this one, I have a 1 times my whole secant, which would be 4, is equal to an x times my whole secant, which would be an x plus an x, or a 2x. So I have a 4 is equal to a 2x squared. Dividing by 2 on both sides, I get x squared is equal to a 2. And taking the square root of both sides, I'm going to just have you round. Let's round to the nearest tenth. It's approximately 1.4. And I'm just having you round because it doesn't specify in the directions what they want. If it asked you for exact, you would just leave it as the square root of 2. Great. Next one, I have 2 secants again. So I do the outside of one of my secants times the whole secant is equal to the outside of my other secant times the whole secant So distributing the 2 in, I have a 2x plus 4. And then a 3 times the 6.5 comes out to be a 19.5. Subtracting 4 from both sides, I get this. And dividing by 2 on both sides, I get this. All right, next one. This is 2 secants. So the outside of one of my secants times the whole secant is equal to the outside of my other secant times the whole secant. 4 plus 4 plus 4. Distributing. Subtracting. And dividing. X comes out to be 2. My next one, I have a tangent in the secant. So my tangent squared is equal to the outside of my secant times my whole secant. Subtracting. And dividing, I get x is equal to 23.8. Great, moving on. My next one, it's 2 chords again. So a portion of one of my chords times the other portion of my chord is equal to portion of the other chord times the other portion of that same chord. So I have a 30 is equal to 8x, dividing by 8 on both sides, I get x is 3.75. They also want you to find the length of each chord. So the length of this chord is a 6 plus 5 or an 11. And the length of this chord is an 8 plus 3.75, which is an 11.75. Okay, moving on. I have 2 secants intersecting. So the outside of one of my secants times the whole secant is equal to the outside of my other secant times that whole secant. It also wants you to find the length of the secants. This one right away we know is 39, 30 plus a 9. All right, so distributing this in, and multiplying a 9 times the 39, and doing the algebra. I'm going to have you pause the video and try the rest on your own. Okay, you get z is 14, and then this secant is 27. For the last one, we have a tangent, so the tangent squared is equal to the outside of my secant times the whole secant. I'm going to have you find y from here. Pause the video, then resume to check your answer. Okay, you get y is approximately 7.3. That brings us to the end of this lesson.